powers and then roots, which you can think of as undoing powers, right? The classical example of this is the square root. It undoes squaring something. So let's recall what it means to be a power. So I say for some positive whole number n, x to the n is equal to what you get from multiplying x, etc., n times. So for example, x cubed would be equal to x times x times x. It is also possible to define powers for non-whole numbers. For example, it is possible to say x to the 1.5, but we're not going to discuss that at the moment. That's a little bit more sophisticated than we need to do for the CLEP. Okay. A sort of important converse to this is what undoes this, right? We call something an nth root if it undoes taking the nth power. So we can see this here. I say if y is equal to x to the n, then we say x is an nth root of y. Another way of writing this is, y is equal to, we had this radical sign x and then an n there. Okay, so as an example, if I take 8 and I want to compute its cubed root, this is equal to 2 because 8 is equal to 2 times 2 times 2. This is just a way of undoing raising something to a power. And it has a variety of notations. You want to be familiar with having this radical sign with an n there, and then also x to the 1 over n is an equivalent way of describing this. This notation is kind of nice from an algebraic standpoint because it tells us that x to the 1 over n raised to the nth power just gives you x, right? So this is another way of saying roots undo powers and powers undo roots. So the same way that addition and subtraction undo each other, multiplication and division undo each other, raising something to a power, and then taking a root, they undo each other. They are all inverse operations of each other. Okay, so that's the way I like to think of powers and roots, is they're analogous to addition and subtraction. So just to illustrate how to compute with this, let's look at a quick example. Right, so I have what looks like a bit of a mess. I have the fourth root of 9 to the 8th power divided by 4 squared minus the cubed root of 8. So this sort of combines a bunch of different things we've looked at. We'll do order of operations, we'll play a little bit with powers, and we'll try to simplify this into something reasonable. Okay, so I would approach it as follows. I have 9 to the 1/4. That's an equivalent way of writing the fourth root, raised to the 8th power. And I'm going to simplify that in just a second, but I don't want to do too many computations in one step. Downstairs, I have 4 squared, 16. And then we just computed the cube root of 8, so you should know that that is equal to 2. Again, that's a nice one to commit to memory. 9 to the 1/4, God knows what that is. It's something that we'll discover is an irrational number. We'll discuss this at the end of the course. But we can simplify this a little bit by saying 9 to the 1/4 to the 8th is the same as 9 to the 8 divided by 4. Divided by, 16 minus 2 is 14. So 14. And then we're almost done. I simplify and say this is 9 squared divided by 14, which is equal to 81 over 14. Okay. Now, of course, it's an interesting question. If I could simplify 81 over 14 further, you cannot. Okay, this cannot be further simplified. Why that is the case is not something we cover in this course because it's not germane to the CLEP exam, but it is a beautiful field of mathematics related to something called number theory, the study of prime numbers. But suffice it to say that we cannot simplify that further, so that problem is finished.